Hi there, folks. Today we're looking at circles and arcs. And circles, you already have an understanding of what a circle is, but the exact definition of a circle is basically a set of points that are all equidistant from a center point. And, the idea behind that is if I start with a center point here, and I measure the same distance in every direction and just start putting an infinite number of points that are all the same distance from that center point, what happens is those points start to run together eventually, and they form what we call a circle. And so as those points start to run together, if they're all the same distance from this center point, I end up with a circle. Okay, that's how this thing is defined, and that's why you have a radius no matter where you go on this circle, is because every point on the circle is the same distance away from the center. Okay. Congruent circles are circles that basically have the same measurements, and really all we need for them to be congruent is that they have the same radii. All right, so if the radius of one circle is congruent to the radius of another circle, the circles are automatically congruent. Okay, that's the only measurement we need, because every single point uses that same radius within a given circle, which means if the radius of one circle is congruent to another, well, all those points are all the same distance from the center as they were in the other circle. Okay, central angle is an angle whose vertex is at the center of the circle. And so, again, if we were to kind of draw a circle here real quickly, so there's my circle. A central angle is basically an angle that we draw from the center of the circle, okay? That's where it's measured from, all right? And here's the thing, there's other angles I could draw within a circle. I could draw an angle that goes kind of the whole way across the circle, but that's not a central angle, okay? A central angle is when that angle starts with its vertex on the center of the circle, okay? So it's just an angle that's centered within the circle itself. For these guys, it says identify each of the following. And again, you should have a working understanding of some of these things already. And so the center of this guy, well, the center of the circle is going to be point P. So we're just going to say point P. All right. And remember, the center of a circle is a point. The diameter of the circle, remember, diameter is the whole way across the circle, that measurement that goes the whole way across and goes through the center. So the diameter for this one would be segment AB the whole way across. The radius of the circle, we have a couple radii of the circle that are drawn, something like segment PA, also segment PB, also segment PC. Those are all radii of the circle. So any one of those could be considered a radius because they all go from the center to the circle itself. And then a central angle, there's a couple central angles I could name as well. Angle BPC would be a central angle because it's an angle whose vertex is the center of the circle. Or we could also name something like angle APC would also be a central angle. I could even go to kind of an extreme here and say something like angle APB would be a central angle, and that would be a straight angle. We just have to be careful as we start to name some of these things in terms of which angle I'm talking about and which arc then I'm going to be talking about when we get to that portion, okay? So any angle whose vertex is at the center of the circle, that's a central angle, okay? So an arc is basically part of a circle, all right? So instead of drawing a whole circle, if I only draw part of a circle, what I have is an arc. So imagine I was going to draw a circle here, and I just all of a sudden stopped partway through drawing it. What I have now is an arc, all right? It still has all the properties of a circle in terms of having a center point that these are all equidistant from. That point just doesn't look like the center because I haven't drawn all the points that are equidistant from that point. But there is still a point that these are all equidistant from, and it would be like the radius of the circle that I was drawing, okay? So right here, if that was the center of the circle that I was drawing, there's still a radius that's consistent between all the points on this arc, okay? So there's a couple arcs that we've kind of probably already heard about. One of them would be a semicircle, all right? So a semicircle is half of a circle, all right? And we have a special name for semicircle just because it's one of those things that gets used quite a bit. So an arc that represents half a circle. All right, and that's an arc that we're probably familiar with. Okay, we've heard of semicircles before. Minor arcs are arcs that are smaller than half the circle then, and major arcs are arcs that are bigger than half the circle. All right, so just like when we measure angles, we kind of base them off of certain sizes. Like I say, an acute angle is less than 90 degrees, but then a right angle is 90 degrees. And then an obtuse angle is bigger than 90 degrees. This is the same kind of thing, except we're using this semicircle as kind of our mark. Okay, and so for this, a semicircle is that happy thing in the middle. And if we're smaller than that, we're at a minor arc. And if we're greater than that, we're at a major arc. For example, here it says identify each of the following. So let's identify a semicircle. And in order to label arcs, what we do is we actually just draw we label the points and then put an arc over the top of this thing. And so for this one, I might try saying something like arc AB. Now, here's the thing. That's not very specific. How do I know if I'm talking about this arc or this arc? Okay? And so if we want to specify between the two, what we do is we use maybe a third value to specify this. Okay? And so I wouldn't typically use something like that. Maybe if I had another value over here called D, I could specify between those arcs by now saying ADB and saying, hey, that's an arc. So just like we do with segments or angles, we use that symbol, okay? And then if I wanted to refer to the other arc, it would be ACB, okay? We wouldn't label it as ABC, all right? We have to draw these in the same way, just like we do with angles, where if we connected these arcs in order, it would give us the arc that we're talking about, okay? Typically with arcs, though, if we only use two values to denote the arc, we're automatically referring to the shortest distance between those 2 points along the arc, okay? For example, if I said minor arc, I could label this simply as BC. I could call a minor arc, okay? Or I could simply call something like AC a minor arc. And there's no danger of me looking at something like BC and saying, well, what if it's B all the way around to C? Okay? What if it's talking about that major arc that goes the whole way around? Well, it's not. It's a rule that if I label this with only 2 points, I automatically use the shorter arc when I'm using those 2 points. If I want to label that longer arc that I have highlighted in red there from B all the way around to C, then I'm forced to use 3 points. So it would be BAC to go the whole way around, okay? Anytime we only label an arc with 2 points, it's automatically the shortest arc that we can draw. Likewise, if I were looking at the second one, AC here, AC automatically labels the shortest arc here. And if I wanted the longer arc going around from A all the way to C, I would have to use 3 points. I would have to say something like ABC for that arc, okay? So again, very similar. This is almost like a combination of how we label segments and how we label angles. So if you kind of think those two things merge together, that's where this notation comes from. Arc measure is essentially just the same as the corresponding central angle. And keep in mind, that means we're measuring this thing in terms of degrees. So if you want to make a little note there, we're measuring the arc as degrees. And really the measurement for the arc in terms of degrees is just the same as the measurement for the central angle in terms of degrees. All right. We'll get into measuring the lengths of arcs at some point, and then we'll be using a linear type of measurement like centimeters or inches or something like that. Okay. But for right now, we're just talking about the measurement of the arc in terms of degrees, which means it just matches up with the corresponding central angle. So it's the same as whatever central angle we're talking about. All right. Likewise, adjacent arcs are just arcs that share the same, that share 1 point on the circle. And so they're on the same circle and they share that 1 point. Basically, they're connected. They're arcs that are right next to each other. And when you think about the central angles, kind of going back to this same idea, the central angles would also be adjacent angles, all right? So if you have two adjacent central angles, and can think about it that way, the arcs that they create are also adjacent arcs, okay? They're arcs that are butted right up next to each other, okay? And so then we have the arc addition postulate. Once again, if we think back to angles here, all right, the angle addition postulate is that if I have an angle made up of smaller angles, when I add up the smaller angles, it equals the whole angle. And it's the same thing here. If I have adjacent arcs, all right, if I add the smaller arcs together, it gives me the overall, the entire arc. Okay? And so again, it goes back to the idea that really this is almost like an extension of the angle. You know, when you think about the measurement of the arc, it's basically the degree measurement of the central angle. And when you think about adjacent arcs, it's basically meaning that you have adjacent central angles. And so now arc addition, well, it's the same thing you would get if you did angle addition with those central angles. And so it's just kind of an extension of what we've done with angles. We're just referring to arcs now in kind of the same measurement scheme. For example, if like these guys says find the measure of the given arc, and so when we look at this, we want the measurement of arc ABC. And so as you start to look at this thing, I have to label all of the different arc measurements. I have arc AB is 74 degrees. What I need is arc BC. And the measurement for arc BC, well, it's going to be the same as the central angle, so 24 degrees, all right? And if I were to add these together then, using arc addition, well, what I have is that the measurement of arc AB, if I kind of write this out officially, measurement of arc AB plus the measurement of arc BC is going to equal the measurement of arc ABC, okay? Or we could just call that arc AC if we're getting technical, because it's less than 180 degrees, because it's less than a semicircle. But again, the whole point here is that, yeah, the two smaller arcs add up to the whole arc. And so when I do this, it's just 74 degrees plus the 24 degrees. And so when I do that, it gives me 98 degrees. So the measure of this guy is 98 degrees. Okay? And again, if I were to kind of jump back into the central angles, if the central angles are the same as the arc, if this is 74 degrees, it's literally the same thing that we've done with angle addition. I'm saying, hey, these two angles together give me the whole angle, which is 98 degrees for that whole angle. The arcs just follow suit. All right? If the arcs have the same measurement, arc addition really just works the same way, where I add the two arcs to get the whole arc, just like I add the two angles to get the whole angle. If I look at the next one, once again, it says the measure of arc AB this time. And so for this one, when I look at this thing, notice I have a couple measurements already drawn here. I have arc BC. I have this piece at 174 degrees. I have a central angle at 62 degrees. Well, I can find the measure of arc AC at 62 degrees. Okay? But now what I'm looking for is this guy right here. And if we kind of think about the circle as one giant arc, well, the circle as one giant arc the whole way around this thing would be 360 degrees. And if you didn't already know that, think about a semicircle. A semicircle is half of the circle, which means that the central angle is a straight angle, 180 degrees, which automatically brings me to the fact that a circle the whole way around is 360 degrees, okay? And so, you know, even think about it as a protractor. When you think about your protractor, that's 180 degrees. To make a circle, you need two protractors together. It's 360 degrees, okay? And so the idea here is we're using that arc addition. So all of these arcs added together equal the whole thing. And so if I call this guy X here, that I don't know, well, then it just means that, hey, X plus the 62 plus the 174 is going to equal the whole arc. Well, the whole arc is 360 degrees. And yeah, I didn't write out the measure of this arc plus the measure of this arc. We went right to the numbers this time, all right? I don't expect you to write out the arc addition as the measurement of the arcs added together. It's pretty much given, okay? And so now I can solve this thing, combining some like terms and then subtracting that from each side. Let me just do that real quickly. That's a 124. Okay, so when I solve this, again, combine these guys and then subtract. So I get 124 degrees. So that's the measure of arc AB. Terribly done, terribly done. B. There we go. Okay? But again, the smaller arcs add up to the whole thing. If I look at this guy, once again, I have a central angle that's listed here, and that central angle pops us out here to 152 degrees. And really, when you look at this thing, I have that center kind of marked. When you look at AB, I don't have it marked this way, but hopefully you can tell that that is a straight piece of this thing, so that is a straight angle. That is a diameter. And, for this one, I should have stated that, like, AB is a diameter. Well, that tells us then that the whole way across here from A all the way to B is 180 degrees, okay? And so kind of stepping back out of this thing and saying, hey, you know what? Let's talk about this from the perspective of arc addition. Well, the 152 plus the unknown angle, maybe I'll call it X again, has to equal the 180 degrees. And so really, it's just a matter of subtracting these things in order to solve this, okay? So even though we call it arc addition, we can do subtraction as well in here because, well, subtraction is a special form of addition, okay? So that's 28 degrees, which means the measure of arc BC is 28 degrees, okay? If I look at the next one, once again, it says I want to find the measure of arc ABD this time. And so again, I just start labeling what I know. And once again, for this one, BD and AC are both diameters this time. All right. So here, this is 22 degrees. If I pop that guy out to the arc measurement. I also have some vertical angles here. So this is 22 degrees based on these vertical angles, which means this is also 22 degrees. And so again, I'm looking at ABD, which is kind of the whole way around this way. Remember, I have to connect them in that order. And so really, when I kind of think about this, there's a couple ways I can approach this. One, you're looking at like those central angles at like APB and BPC. Those are a linear pair when you look at them because they form a line. So you could find it that way and say, hey, you know what? Let's go the route of angle measurements and say, hey, has to be a 158 degrees because these two have to add up to 180. And so now I can pop that angle out to the outside. That's a 158. Well, now I have all three pieces that I need. It's just the 158 plus the 22 plus the other 22 to give me the whole way around that arc. And when I add those together, I get a 202 for this one. So the measure of arc ABD is 202 degrees. Okay. The other option here is I didn't have to go that route. Again, I just kind of jumped into that. I mean, you could just look at it and say, you know what? One of these pieces is 180, looking at AC. So right here, from A to C. So right here, that's a semicircle. That's 180 degrees. And now if I pop this arc out, that's 22 degrees. And now the whole way across, if I add those two together, well, that's the 202 degrees. So there's lots of ways to kind of approach this. You just kind of have to take what you have, look at what you've got, mark the arcs that you have, look for any arcs that are kind of given in terms of their measurements based on the fact that we have 180 or 360, that kind of thing.